Good morning, everyone. We are the Group 8 and let's talk about thiols. So what is thiol? Thiols can be defined as a sulfur analog of alcohols. That is, in simple, it is an organic compound consisting of compounds with a sulfur atom. It is also referred as mercaptan and it consists of sulfhydryl group. Alcohols and thiols share some similarity. That is, sulfur emerges to be a larger element compared to that of oxygen. The length of carbon and sulfur bond is more than that of carbon and oxygen bond. The hydrogen bonding between the thiol groups is much weaker in liquids or solids, mainly because of the cohesive force. They exhibit low dipole moment than alcohol.
Thiols have the general structure of RSH. It is a molecule that has R bound to SH, where R represents the rest of the molecule and SH as the functional group. The R is any carbon chain or group, and attached to one of the carbons of that group is a sulfur atom and a hydrogen atom. Let us have ethene thiol as an example. In the structure, the carbon-containing group at the left side of the sulfur atom is our R group. Attached to the R group is an S and an H, and that matches with the general structure for thiols. As we can see between the structure of methanol and methane thiol, alcohols and thiols have similar general structure. In thiols, we have sulfur instead of oxygen.
Properties of thiol. Many thiols consist of others that are usually strong, which may be a resemblance scent of onions and garlic. Thiols possessing a low molecular weight consist of repulsive and strong smell. For example, consider skunks consisting of low molecular weight of thiol and easily detectable by humans. It is also responsible for some sort of wine faults that are resulted due to some unattended reaction caused between the sulfur and the yeast. However, not all kinds of thiols hold bad odor. There are many other thiols with a pleasant smell. For example, furan-to-yield methane thiol, responsible for beautiful aroma of roasted coffee, and monocapenoid thiol, responsible for mesmerizing scent of a grapefruit, and this can only find at the low concentration levels. Moreover, thiols are less likely soluble in water. Other functional groups possess similar boiling points and solubility features, and this is not all true for alcohol. Volatile thiols can easily be identified due to their distinctive odors. Lastly, thiols, unlike alcohols, do not form hydrogen bonds, and therefore, they are volatile, low-boiling compounds.
Sulfur is a row down from oxygen in the periodic table. Compounds that contain sulfur instead of oxygen may be expected to bear similar characteristics of the oxygen compound, but their chemistry is different from each other. The SH group is called a sulfhydryl function, but organic compounds containing the SH are called thiols in the IUPAC system, or called mercaptans in older nomenclature. Thiol nomenclature is relatively similar to the nomenclature of alcohols. However, instead of adding the suffix ol or ol as in the case of alcohols, thiols are usually named by adding the suffix thiol. Thiols prepared from alkenes retain the e in the name of the alkene. For example, butane thiol and ethane thiol as opposed to the alcohols butanol and ethanol. A number is used to locate the position of the thiol. Other examples, as you can see, are 2-pentane thiol and 2-chlorocyclopropane thiol. The SH group of a thiol is known as a mercapto group, and therefore the prefix mercapto may be included in the names of the certain compounds. For example, 2-mercaptobutanol and 3-mercaptocyclohexanol. When a thiol is named relative to a corresponding oxygen compound, the prefix thiol is used. For example, thiophenol.